That silver solder is a little close to that bolt there that's acting as a heatsink, but I'm sure it'll be fine. Wait, did I just silver solder that bolt onto the tube? Hello Internet, my name is Quentin and this is Blondihacks. I'm back on the Firetube boiler project today, and it's a great day on this project because I'm going to silver solder the Firetube core together. As I said in the previous video in this series, my plan is to do it in 2 stages, and I'm going to do stage 1 today, so let's go. Yeah, so that didn't go quite as I'd hoped. Let's try that again. Yeah, when you weren't looking, I went ahead and made all those parts again. Now, you'll notice some subtle differences here. The first is the tube diameter. I switched from 26 3/8 inch tubes to 15 1/2 inch tubes to simplify the geometry of the boiler. I ran my boiler calculator spreadsheet again that I showed earlier in this series, and by increasing the tube size, I have a 50% reduction in tube count, but only a 30% reduction in tube surface area and thus steam production. So I'm still well within the margins of what my engine is going to need, and this will be a much simpler geometry to build. And I made all new bushings, of course, and there's some changes to these as well. The flanges are shallower, and I've also put a heavy chamfer on them to help the silver solder flow down in behind them. And the main shell bushings are the same size, but also chamfered. The stud retainer system remains the same because that worked really well last time. I'm going to make a fixture to suspend the tube sheets in space the right distance apart so that I can solder the core to the tubes separately as a preliminary operation, just as I described at the end of the last video on this boiler. So I found some brass in the stockpile that should do the job. So I cut some lengths of this. Over to the mill, and I'll tap the first piece in, and I'm cleaning up one edge of each piece. I need these bars to all be exactly the same length, but the actual length doesn't matter very much, so this is a quick way to do that. After cleaning up one end of each, I pick the shortest one, flip it around, put it in the vise, and then put an end stop on the machined end there, then machine the other end of this piece. And after that end is cleaned up, I zero the y-axis of the DRO, and that's now my length for all these pieces. So then I can just put in the rest of the pieces. The rest of them are all longer than this because I started with the shortest one, so I just machine the ends of the other 2 down to 0 on the DRO, and these pieces will all be exactly the same length. So here you can see the final result. Those are all identical in length to probably within 1/1000th. And I'm going to find the end and the center line with my edge finder, and I'm going to drill the first through hole here. I'm going to use the stud mounting holes that hold the tube sheets in the shell during silver soldering. Those are going to get reused for this fixture. So these are just clearance holes for 540 screws, which is what those studs are in the boiler shell. Once again, using the end stop to just make sure that all of these holes are the exact same distance from one end of each bar. And then I go down to the other end using the DRO, and I tap that parallel out of the way, and I drill the other hole a very specific distance from the first hole. What matters is not so much the length of these bars, but that the spacing between the holes is perfect. Now it also matters that the bars are the same length from one end to the first hole, so that when the bars are all sitting on the ground, they're all holding the tube sheets flat and square. So I center punched the reference ends of these bars so that I can keep them in the same orientation. To keep the tubes in position, I have this round piece of ceramic board here that'll take the heat no problem, and it's going to hold the bottoms of those tubes just slightly below the lower tube sheet. So now I can slide the tubes in there, and let's see if this is actually going to work. This all relies, of course, on those brass bars holding the tube sheets square and parallel to each other, and that does seem to work very well. So I'm cautiously optimistic that this might actually work. It's looking pretty good. One potential challenge here is getting the heat into the inner tubes. You can see that this forest of tubes kind of blocks the center tube there, so I'm worried about that. However, I have an ace up my sleeve. If you turn it to where the bushings live, there's a gap here where the heat can get all the way into the center tube. So I'm going to be using that area there on each side for most of my heating. I considered doing the tubes in concentric rings. I know some people do it that way, but if you look back at the top here, I've got a couple of tubes that are really close together. I didn't realize how close these were together until it was too late. And so I'm worried about trying to do that in separate rings and having the solder pile on top of itself, trying to make two different joints. So I want to do all of the tubes at once so that this is effectively one joint. Before I attempt the final silver soldering though, I'm going to do some test parts. I often do test parts or test cuts on a machining operation that I'm unfamiliar with or unsure about, but for some reason it never occurred to me to do this with silver soldering. So here we go. I've got a bunch of scraps of copper and a leftover tube here that are going to go in the pickle bath, and I'm going to do a mock-up of all the operations I need to do and verify some assumptions here about how this is or is not going to work. So after pickling and cleaning up those parts, I'm going to flux them all here together. Now you can see that I'm using a new flux here. This is the black flux. I've been using the white stuff previously. Same brand, just comes in black and white versions. The black stuff has boron in it, and that gives it a couple hundred degrees of wider temperature range. And basically every experienced Boilermaker I talked to recommended this stuff because it just gives you a lot more margin of error on the heating before the flux spoils. Plus, this is clearly the evil flux. Okay, I got a ring of my silver solder on there, set up a little fixture here of fire bricks, and let's apply some heat and see what happens. Now, obviously this torch is much too large for this little job, but it's a very convenient one to use, and I've just got the gas pressure turned so far down that this thing wouldn't even cook a hot dog right now. I also wanted to do this test so I could get used to the black flux and what the stages of it look like. So once that solder flowed, I could already tell, honestly, that this was not a good joint. You can see that it didn't get a nice fillet on either side. I pickled it anyway, and you can see that very little solder flowed through, and I didn't get a fillet on either side of the joint. So I wanted to try that again and figure out what I did wrong. What I did wrong was actually applying too much heat to the sheet and not enough to the tube, because of course the solder chases the heat. So you want to heat just the tube so that the tube will pull the solder through the joint. And that's how you end up with a nice fillet on both sides. And my clearances on this hole, I think, are also a little too low, which was adding to the problem. Once that second attempt worth of solder flowed, things were looking much better. I could already tell that looked like a better joint. And once again, pickled and cleaned, and there we go. Now there's obviously excess solder on the top because I did it twice, but that is a very good looking joint. Except for this area back here, it's a little bit light back there, and I think it's because the clearance on my hole is a little bit too small. So lots of learnings here. Now I'm going to do the same thing on the other end, and the test here is to see, can I solder the other end of the fire tube without ruining the joint that I just did at the previous end. This is going to be very important for my core, obviously. So once again, I flowed the solder using the heating technique that I learned from the first one, and that second joint went perfectly first try because I heated the correct place. You can see how the difference between success and failure in silver soldering is a couple of centimeters one way or the other on where you put the heat. But the good news is no sign of damage to the older joint, and I could tell while doing it that not that much heat was actually making it to the other end of the tube, so that's a good sign. Now I want to test the second part of my plan. I've got my usual Harris Safety Seal 56 here that I've been using. I've got more of that stuff here, different brand, but same composition. Now I've got this other stuff. Now this is cadmium-based silver solder. This is what the Brits often call Easy Flow number 2. Also low melting point, a little bit lower than the other stuff, and it has cadmium in it, which flows much better, allegedly. So this stuff I've never used before. The cadmium stuff is banned in a lot of countries, but you can still get it online in a few places. And you definitely want to wear a respirator while using it because cadmium fumes are not so good for you. So the test here is to see, can I silver solder using this lower temperature stuff right next to the old tube joint without damaging that joint? Because this is what I'm going to be doing when I come to do the shell. And you can see that that worked really well. That cadmium stuff really is nice. It does flow noticeably nicer than the cadmium-free stuff. I can see why people like it. I don't think it's enough better to necessarily use it all the time, but for a case like this where I need 2 heat ranges of silver solder, I think it's an excellent choice. All right, well, I think I'm ready for the real thing, so I dismantled everything, and I want to double check some clearances here because I got a new boiler book a viewer recommended. This is Model Locomotive Boiler Making by Alec Farmer. It's an older book out of print, but it's still pretty easy to find online. I got mine from Abe Books, which is hard to say, but they have lots of copies, and I really strongly recommend it. So I'm going to implement a few tips that I got from that book. The first is to open up my tube holes a little bit. The standard they suggest in that book is that the tubes should simply fall through under their own weight. If not, the tube clearances aren't good enough there. So that's a really good tip. I cleaned up and opened up these holes a little bit to meet that standard. And then the second big suggestion is a deep chamfer on both sides of every tube hole, much like you would do when welding a piece of thick steel plate, for example. And that really allows the solder to flow down into that joint and gives it a nice purchase place for the fillet. And then the final real magic trick is to take a small triangular file and file a little notch in 2 places on each tube hole. And this is really clever. What this does is, in the event that the tube gets hotter than the tube sheet and expands and tightens up the joint, those little triangles still give space for the solder to flow through to the other side of the joint. Because overheating the tube a little bit is very easy to do, and you'll never know that it's happened, but the joint will be no good because it closed up during the heating. All right, nothing to it but to do it. Let's get all these parts into the pickle bath and get everything ready for silver soldering the real thing. To prepare the silver solder, I'm going to use a trick that many people know, and I didn't know the first time I did this, which is simply to wrap the silver solder around an extra tube the number of times for the number of rings that you need, and then you can simply cut them apart and you get a whole bunch of nice perfect rings to go around all of your tubes. Now, one thing I do recommend is using a form that's a little smaller diameter because the silver solder actually does have a lot of spring to it, as you can see. So I ended up with rings that were a little bit oversized, but it was pretty straightforward to smush them down a little bit. All right, the pickled parts get reassembled in the fixture now. I'm also going to decant some of the flux into a separate container. This was a suggestion from a patron as well, just to keep anything from contaminating the main container there. Seems like a good idea. I have noticed that my old bottles of flux do get pretty nasty towards the end, and well, it's hard for the flux to clean the joints if it is itself contaminated with crap. So as usual, I fluxed both sides of every joint and the insides of the tube holes and the tubes themselves, and then I carefully slide each tube into place. Of course, I'm only fluxing the tops here because I'm doing one end of this core at a time. I'm just using the bottom tube sheet as a fixture basically to hold everything in place while I do the tops. And then of course we can't forget about the bushings. They get fluxed and set in place as well. And then I place the rings of silver solder around the bushings and of course all of the tubes. Big moment, under the torch it goes. So you can see I'm leveraging that gap that I pointed out earlier to get to the center tube. And I've got a Lazy Susan under there to try and heat everything up kind of at the same time. Make sure nothing gets too thermally stressed. And so with everything kind of generally warm, then I start focusing on one area. And I focus on a couple of tubes at a time until the solder flows on those tubes, and then I start working my way around, flowing each 1 or 2 tubes as I go around. I wasn't sure how this was going to work, but it's actually working really well. The heat is getting into the center there, and as I work my way around each of the outer pairs of tubes, the center tube did end up actually flowing on its own without too much effort. So I was very pleased with how this worked. You can see I'm focusing the heat really only on the tubes. Some of it is of course splashing up on the tube sheet, and the tube sheet being horizontal is going to get a lot of the heat rising off of the torch, but in general I'm trying to keep the heat only on the tubes to pull the solder down through those joints. And when I think it's done, I hit it with some heat from above to just make sure all the solder is flowed and, make sure there aren't any lumps left over. You'll see later that I didn't actually succeed at that. I did have some lumps left over up there, which looks a little amateur, but is basically harmless because I did have sufficient extra solder on here that even though not all of it flowed, I still have plenty in all the joints. And I do a quick inspection of the undersides of the joints before it cools too much, because it's not too late to make fixes here if something didn't flow properly or if something needs a little more solder, something like that. And in fact, I did find an area that wasn't crazy about. This outer tube here looked like it needed to flow better, so I did heat that up a little bit and jiggled the solder a little bit just to make sure it was flowing, and the joint looked better after doing that. So then I decided I was finished, and then I covered the whole thing with a ceramic blanket to cool it all as slowly as possible. That took 30 minutes to cool to the touch, and so far it's looking pretty good. I think I have good joints on all of those tubes. It's hard to tell though with all the flux and crud in there, so let's get this fixture taken apart and get it into the pickle bath and clean it up so we can see how we did. That ceramic disc on the bottom worked really well to hold the tubes in place. The lower tube sheet in principle will come off because it wasn't soldered, but it's pretty stuck on there. Probably heat and flux residue melted in there, something like that. So I'll put it in the pickle bath and remove it after the fact, after all the residues and things are dissolved. And so far that's looking pretty good. So I gave it a good thorough cleaning in clean water, and I also used a plastic brush to get into all the nooks and crannies. The pickle bath loosens up all the soot and residue and everything, and it'll just wipe off with your hand, but the brush is handy for getting into all the tight spots. That is looking pretty snazzy now. It always comes out of the pickle kind of dull pink, and that looks very good actually. Those joints look really nice. You can see how it flowed all the way through the joints to the back sides of the tubes there, and I've got a nice fillet on every joint. There's one joint right there that's a little suspect. I didn't get a full fillet on the back, but there is a ring all the way around, so I did get good penetration. And you can see that the tubes that are close together that I was worried about actually flowed really well. So I think soldering all those at once was the right move. I did get some excess running down the tube there, but that's harmless enough. And now let's see if I can get the bottom tube sheet off. It wouldn't pull off even after pickling, so a little percussive persuasion should do the trick here. It's just friction and residues and things holding it on there. That worked really well though to hold the tubes in place. So that is looking very good. And the center tube there even got a really nice fillet all the way around it. I was worried about that, as I said, but I think the method that I used worked really well. I see no trouble with that joint at all. So back into the pickle bath to get ready for the lower tube sheet now. And for this, I've got another trick up my sleeve. I've got a whole bunch of bolts that are a good fit in the tubes, and I'm going to plug all of the tubes that I just did with these to increase their mass, so that as I'm heating the other ends of these tubes, if by chance I tend to overheat the bottoms of the tubes a little bit, then they won't be able to hit silver solder temperature with the extra mass of those bolts in there. So flux all the joints again, reassemble the fixture to hold everything in position, and then once again apply all of my silver solder rings, and we're ready to go for the other end. Now something to note here is the other end is a different brand of silver solder. It's ostensibly the same composition, it's the same melting temperature, and they're both cadmium free, but it's a different brand because I ran out of the Harris Safety Silv, and I had ordered this other Prince and Izant stuff from McMaster Carr that I showed earlier, and what's notable is that this stuff is much lower viscosity. It's very, very thin when it melts, so that was a difference, and we'll see how that looks on the final product. But the bolts all came out, and who knows if they helped, but I felt good doing it, so Once again into the pickle bath, dear friends, and out it comes, and you can see that the joints mostly all flowed well. I got one tube there where I did not get penetration in the joints, so I'm going to have to fix that. Otherwise, things look good. And on the top, you can see that overall, it's all much thinner. There's very little fillet around each of the tubes. So that's an interesting difference. Now, in addition to that one tube, I had also a pinhole leak on the center tube. And I don't have a good shot of it here, but the hole was actually one of those triangular notches that I had filed to help the silver solder flow. So it's a bit of a double-edged sword there. Be careful not to make those notches too deep. I really do think they're a good idea. I feel pretty good that they probably helped. But yeah, don't get carried away because I did create a hole doing that. But now to see if I can repair tubes, which is something I could never do with my previous method. So in addition to fluxing and placing the solder, I'm also plugging all adjacent tubes with bolts so that they won't hopefully get overheated. And really the key difference here is that I can easily heat the back sides of the joints, which is something that I couldn't do before, which makes tube repair so much easier. I don't need as much heat and I get a better repair. Now for that center tube, I did have trouble getting the solder to flow without overheating. I felt all of the tubes around it. So I got the whole sheet up to close to silver solder temperature, and then I got in there with my small hardware store Map Pro torch. And it's got a small nozzle on it, and that actually worked really well. That got that center tube to flow with very little effort. So I actually prefer that to acetylene, which is the other thing people might use for a targeted fix like that. I pull all the bolts out. Some of them are a little stuck because there's flux residue in there. I fluxed the whole tube sheet just in case any of the solder remelted. It wouldn't cause a new leak because it's all been fluxed, so it'll stay clean. But that one bolt there is a little bit stuck. That's strange. I'm sure we can get it out. A little more force didn't help. I don't want to put too much force on it because it's just sitting in a soft copper tube. What happened is the solder ran up onto the bolt a little bit, so I tried grinding it away with the Dremel, and I couldn't get in there in a way that felt safe. I was afraid of damaging the tube sheet there. So I thought, okay, it's just a thin little ribbon of solder that happened to touch the edge of the bolt there, and that's what's holding it in place. So I'll take it over to the mill, clamp it up, and just mill away that little bit of the edge of the bolt there. And oh, there was some over there too, and oh, there was some on the back. Oh, and there was some kind of on the side here. And yeah, I think it might be all the way around the bolt. So plan B, I tried drilling it out, and I'm starting with a very small drill and working my way up in a lot of small sizes because I can't clamp this thing very tight because it's all soft copper at this point. It's mostly been annealed from the heat as well, so I really can't put any amount of tool pressure on this because I can't clamp it very effectively. So I'm just trying to only do machining operations that are going to have super low tool pressure and not put any stress on anything. So I went up in a bunch of very gradual drill sizes, and I got up to a size that was slightly smaller than the tube, and now I could see the silver solder was very thoroughly penetrated all the way around that bolt. Wouldn't you know it, if I don't do everything exactly perfectly, the tube joints don't work. Yet this bolt, which was not fluxed, not clean, not a very good joint, and had no proper heat applied to it, somehow ended up with a perfect silver solder joint all the way around it. Yeah. So I had to mill away the entire bolt head, which again, because I'm trying to apply no stress to that joint at all, I had to do in very, very light passes. I milled away that entire bolt head 5/1000ths at a time. Yep, that took a while. But after the effort I've put into this thing, I am not taking chances. So I got it very close to the top surface of the copper tube there, and then I cleaned away the remaining top layer there with a little grinder, and I used a deburring tool to clean out the inside of the tube. That remaining kind of flat thing there is a combination of silver solder and maybe a little bit of the bolt, but I didn't want to get crazy trying to get rid of all that, so I'm going to leave that in place. If there's anything ferrous left in there, it's going to rust away over the life of the boiler anyway, and it won't hurt anything. So that repair was a success, and that was a close call, but you can see that I did succeed in fixing that joint, so I'm pretty happy with that. Oh, and I found the remains of that bolt in there. How about that? Now, after all that heating and poking and prodding and everything, I don't actually expect it to fit back in the shell again. I'm sure I'm going to have to modify things to get it back in here, but let's do a little test fit anyway to see how bad the damage is. And oh my goodness, would you look at that? It just slides right in as though it was built for it. Somehow that core survived all of that heating and poking and prodding and milling and everything. So I guess my fixture really did its job because it actually held everything in really good alignment despite just being a couple of simple brass bars. So very pleased with that. I'll do a little bit of sanding to the clearances in there, but basically it's a perfect fit. It just slides right in. So that is a big win. I'm very excited about this. The pressure test will say for sure if these joints are any good, but they look better than any joints I got on my previous attempt at this boiler. So I'm feeling really good about it. That's what I got for you today. I hope it was good for you. Thank you very much for watching. And hey, if you can swing it, throw me a little love there on Patreon. Much appreciated. And I will see you next time.